If you can't see that tiny writing at the bottom, I'll write it at the top of the board. So you're going to define and graph linear functions. Solving for y first. Look at your warm-up problem. And I'm going to have you turn and talk in just a second. I'm going to define and kind of redo the turn and talk procedure. But here's your warm-up from today. It was y equals 5 over 2x minus 5. Y equals 5 over 2x minus 5. Write that in the middle. You're probably noticing something that's different. I want you to turn and talk and state what's different, and then think through and brainstorm what might be a good next step if I want to graph this. When I say turn and talk, there will be occasions where I say odds or evens. Look at the top left-hand corner of your number. If you don't have a number like Frankie, I got, you are 20. What number are you? Yeah, you're 21. Yeah. Right. That's 24. What are you? Okay. Okay, for now, you're 22. What are you? You're 25. This will be 22. What are you? Yeah. Okay, for the sake of today, I'm going to have to relabel the desks, but if I say odds and you look at your desk and you have an odd number, you're going to be talking first. I'll say turn and talk odds. I'll state the question and go. The odds are the only ones that are talking. You might be an even and be like super excited to share. You're going to wait until the odds have finished. If the odds are done talking, you can add in if we're still having time to turn and talk, but the odds go first. I might switch and go evens, turn and talk, evens go, the evens start talking. This is a play, kind of like in basketball. We have a few like procedures in here like entrance or like partner work where we run plays to learn. Turn and talk is a play that really allows me to see who has ideas, and you all do have great ideas, but it allows just for equity of talking across the classroom. If you turn and talk and say, I don't know, that is not a turn and talk answer. If you're not sure and you get called and you're talking to your partner, you can say, I'm not sure, but I think, or I'm not sure, I'm confused about, I'm not really sure, what ideas do you have? All those things are okay, but just saying I don't know and shutting down is not a great use of that play. If you don't talk, that completely breaks the play. And so if I see turn and talk odds and the odd just has a head down, that might be counted for off task. So just make sure that you are engaged. You should be tracking the other partner. You should be like agreeing or disagreeing, and then the evens can talk afterwards. First thing you're going to tell me, if you're an odd, raise your hand. Odds, raise your hand, and if you aren't sure because your number is like erased, just kind of guess. Okay, hands down. If in the case that like Abby doesn't have a partner, Mackenzie doesn't have a partner, you guys are just going to like slide over and briefly talk. It'll be quick, but you can like lean towards each other and just talk about the answer. Odds, you are starting first. What is the difference between number 1, today's problem, and your warm-up? And it's pretty obvious. So the second follow-up is, what would I do to change up number 1? So I could graph it. Odds, you're starting, you have 30 seconds, go. Tessa, you're gonna talk to me. 5, 4, 3, 2, 1. Okay, track me. When I ring the bell, the second part of the play that's really important is the follow-up. So if you are in the middle of conversation, usually I'll try to time it so you get most of your conversation out, but there might be times where we move on. I'm going to cut you off. It's not because I'm being rude, I just want to get to the next part of the lesson and then hear from everybody. So if you're in the middle of a great idea, even if you're starting and talking and sharing. When you hear the bell, you're back tracking me. You can go to swag if you want to. Sit up straight. Just make sure that you kind of reset yourself. What is the difference? I started hearing it around row number 2. Did you guys chat about anything, Peyton, row 3?
Yeah.
What was your difference? Oh, so the y is isolated, and this doesn't have y isolated. Any ideas of what I might do to graph number 1? I'll take a silent hand. Mackenzie. You could subtract y, and you'll end up with a negative y over here. That could work. Any other ideas? We're starting to get there, Avery. You could also subtract 4x. That would leave y positive. So let's take number 1, and just to the side, let's go 4x plus y, rewrite the problem. If you want to get y isolated, you could subtract 4x. That leaves you with y equals 4x or negative 4x plus 0, which you could write as y equals just negative 4x. Yesterday, you noticed that all of the problems, including the warm-up, had y isolated. There's a reason for that. I started out just as simple as I could make it so that we weren't having to navigate through a whole bunch of steps. But in order to graph for today, you need to isolate the y. That means get it by itself. Later on this unit, you're going to see why, no pun intended, why the y is isolated, but I'm not going to go into that detail now. It's a huge equation that you're going to live with for the next like 3 or 4 years of your life. But for now, just know the y has to be isolated to graph. So let's start putting in functions into the function machine, or inputs into the function machine. Just like yesterday, you're going to have your function, which is y equals negative 4x. And we need about 2 different points. Give me one input or value for x that you want to start with, Jacob. Yeah, you chose my favorite one. Negative 4 times 0 is 0. So this point is at 0, 0. Go ahead and plot it. Give me another input for x. There's lots of different options we could choose. Jada. Let's see what happens. Negative 4 times 3 is negative 12. So I'm going to get 3 negative 12. That's not wrong, Jada. It's just a little tricky to graph. And so you can go ahead and put 3 into the function machine, but when you get a 12, let's just kind of note, I don't want to regraph like an entire thing, so let's go on to the next one and choose a different. Yeah, Claire, which one do you want to choose? Let's try it. It's negative 4 times negative 1. Liliana, what is my output when the input is negative 1? What is negative 4 times negative 1? Close. That's a minus. This is like multiplication. So think of 4 times 1. 4. You got it. So your point is negative 1, 4. Go up. Go left 1. Run before you jump. And down 4. Is that wrong? Ooh, thanks. What's my blunder? Yeah, I went down 4, not up 4. Thanks for marking it. Blunder marker. Over 1, up 4. Looks like that. Take your geo template, make a nice straight line. Make sure they have arrows. There it is. Last one. 10x minus 3y equals negative 15. Let's clean it up. My goal is to isolate for y. What would I move first from this one, Milo? How do I move it? What would I do to both sides? Good. So let's do minus 10x. And I get, ooh, it's going to be weird. Negative 3y equals negative 10x minus 15. You get in the habit of always placing the x first, even though it was negative 15 minus 10x. It's going to come in handy later to have that x listed first. Ooh, this is a weird one. Next step, what would I do, Jacob? Oh, dear goodness. Did they really do this to us? Okay, that's fine. Oh, you know what? Yeah, we'll be okay. You get y isolated. We're happy. 10 over 3 and negative 10 over 3 are equivalent. So think of same good, different bad. 10 over 3x is that one. And it's a plus 5. Negative divided by negative is a positive. Okay, take your function. Build a function machine. Give me an input that you want to start with, and we'll see if we can graph it. Jersey? My favorite input. Let's try it. 10 over 3 times 0 is 0, plus 5 is 5. Great, that one fits. Over 0, up 5. Give me a second one. Peyton. Yeah. Did you do like that? You're not wrong. That's the same, you're doing the same process, just writing it a different way. If you did put it all together, they're separate terms, so you still have to divide every single one by 3. So because the x is different from just a number, 10x is different from 15. That's a variable. That's a constant. That's a variable. That's a number. So you'd have to divide each of them by a negative 3. Thanks for asking that though, because a lot of students were nodding at you like, wait, I just did like 1, 3. Does that make sense? Okay. We got 1 point. Give me a second point. Silent hand. Ashlyn. Let's try it. We may have to go back, but let's see. 3 over 1. Uh-oh. I got 15. All right, that's okay. Let's try a different one. If 3 didn't work, what could I try, Jada? Yeah, and 2 is a good option. You're thinking like going down, but I still want a fraction bust. And so what would be another version of 3 I could put in here, Tessa? 10 would be like 100 over 3. That's going to be huge. It's going to be like 60. Let's try negative 3. Yeah, we want a fraction bust still. Just change the sign. Negative 3 over 1. Okay. Raise your hand if you think you have that answer. 10 times negative 1 plus 5. Brady, what'd you get? Yeah, negative 10 plus negative 3, negative 5. I didn't catch that first blunder. Thanks for fixing it. Sorry, let me scroll up. Okay. Negative 3, negative 5 is point number 2. It fits just barely on the graph. Connect your dots. Nice straight line. It goes through both points. I could maybe change that a little bit. Okay, almost done. Just another special case. Next page. Yesterday you saw something that looked like this. It said y equals 3. And for the special case, I was telling you, you don't even have to make a function machine because you know that the 3 is where it crosses at the y-axis. If they give us a special case, you don't need to write this right now. I'm just making an example. So y equals 3 looks like that. If they say x equals 3, what would it look like? Silent hands. I'm going to give you 5 seconds to think about it. What would x equals 3 look like? Turn and talk, evens, you're up. Evens, raise your hand. If you're an even, raise your hand. Even, raise your hand. You guys are just going to decide who talks. Abby, hands down. Lillian, are you even? Okay. You have 20 seconds. Evens, what is going to be different about x equals 3? Start brainstorming. Go. Get ready to track. 3, 2, 1. And love the conversations. So much respect in turn and talks, and just a lot of great ideas that are shared in a short amount of time. I saw like nodding for odds. I saw some feedback from odds after the even spoke. Excellent job. Silent hand, where do you think x equals 3 would cross? What would it look like, Jacob? Which direction? Okay. What's the line going to look like? Vertical. Label your axes. I heard some discussion about, wait, where's the y-axis? The y-axis is this vertical line. And so if it crosses the y at 3, it's going to go across it in a horizontal way. If it crosses the x-axis, the point is on the x-axis, it's going to be a vertical going up and down. Special cases that you really just kind of have to have memorized. Big idea, last bit of notes. A linear equation with the form of x equals some number will yield a vertical line parallel to the y-axis. Try x equals -4 in the next 30 seconds. You can chat with the partner. Where would that go? What would it look like? Fill in this graph with x equals -4. All right, 3, 2, 1. X equals -4 would look like this. If you have x equals or y equals just a number, those are the two special cases. Those are the only two times on homework or on bronze for today that you don't need a table. So if you see x equals a number and you're trying to solve it with a function table, that's not necessary. These are the special cases that really just kind of have to be memorized. Next page. Yay. You have Independent work? Where are you? Bummer. Wait. Oh. Yeah, you're on the right page. Cool. Scan through the first 2 pages. Do you see any of the problems that look like y equals just a number? Or x equals just a number? I don't think so, right? Okay. They will pop up in the future, so just hold on to this note packet. I think most of the other ones are just like example 1 and 2. So go ahead and start on 1. You have 10 minutes. I'm okay with a little bit of whisper talk if you get stuck, and just check your answer after each problem. Make sure you have a straight line. Use your geo template appropriately. Go. This is the right step. And you get here. You put the 2x there. But you should actually, right? So you should have minus 2x. So it's going to be negative 6 minus 2x. Now divide everything by negative 3. You get 2 minus. Oh, sorry. So you also divide that by 3. That was Steph's question. So if you have a negative 2. Negative 2x divided by negative 3 would be what fraction? But if they're both negative, you can change it from positive 2 over 3. Something kind of funky that I want to avoid confusion on